Alright, today we're looking at the discriminant. The discriminant is that part underneath your square root in the quadratic formula. So normally in our quadratic formula we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this b squared minus 4ac, that part underneath. So the discriminant is always b squared minus 4ac. What that discriminant tells us is it's going to tell us the number and the type of solutions we have in our quadratic formula. So depending on whether underneath your square root is positive, negative, or 0, that's going to tell us about our solutions. So knowing that, so if b squared minus 4ac, if that is positive, then we're going to have two real solutions. The reason being is we'd have x plus something divided by 2, x minus something divided by 2, and because there's not a negative number in there, there's no i's, we know that they're real solutions. Graphically, that's going to look like this. Your parabola will cross your x-axis twice. If your discriminant is negative, so if you're taking the square root of a negative number, we know whenever we take the square root of a negative, we get an I, which is an imaginary number. So this is going to be two imaginary solutions. We also call them complex, so I'm going to write complex. So there are two imaginary solutions. This also means that there are no real solutions. So sometimes we'll say two imaginary, sometimes we will say no real solutions. They're all imaginary. And graphically, because there are no real solutions, that means it never crosses the x-axis. It's going to be a parabola that's either above or entirely below the x-axis. So it could be facing down and be below, but it never crosses that x-axis. And finally, if your discriminant is 0, so if you type in and you do b squared minus 4ac and you get 0, so that means you're taking the square root of 0, which is 0. So if you think about it up here, this would be negative b plus or minus 0. That's not going to change anything. So you really just have negative b over 2a. That means you only have one real solution. So one real solution. We also call this a double root. The reason being because this is when your vertex is on the x-axis, and we've talked about this before. That means when this is factored in factored form, it's like x minus 4 squared. It's that double root. So there's only one real solution. Sometimes we call it a double root. But that's when your discriminant is 0. So if our discriminant is positive, we have two real solutions. Negative, we have two imaginary solutions or no real solutions. If it's 0, we have one real solution. What we're going to be doing with this is I'll either give you a graph and ask you to tell me the number and type of solutions, or I'll give you an equation and ask you to tell me the number and type of solutions. So your directions would say give the number and type of solutions. So the number would be 1, 2, or 0, and the type would be real or imaginary of solutions. Alright, so if we're going to do two quick examples. If we have x squared plus 3x equals 2, first thing, this has to be set equal to 0, so we've got x squared plus 3x minus 2 equals 0. So to find the discriminant, again, our discriminant is always just b squared minus 4ac. So we're going to do that for this problem. A is 1, b is 3, c is negative 2. So we're going to do b squared, which is 3 squared, minus 4 times 1 times negative 2. So this would be 9 plus 8, because negative 4 times negative 2 is positive 8, which would give me 17. Because that is positive, so we know from the previous slide when that's positive, we have two real solutions. So the discriminant is 17, which means we have two real solutions. If we do another example, so if I give you, let's say, x squared plus 8x plus 16 equals 0. Here a would be 1, b would be 8, c would be 16. So we're going to do 8 squared minus 4 times 1 times 16. 8 squared is 64. Negative 4 times 1 times 16 is negative 64. So 64 minus 64 or plus negative 64 would be 0. That means we have one real solution. So the discriminant would be 0, and we would have one real solution because of that. That's just going to help you know graphically what it looks like, and as you go in to solve the problem, what your answers are going to be.